Okay. So I'm not sure where your brothers are, but we're going to go ahead and get started. I'll look for them again at the 15-minute mark. Let's see. This thing has been acting up all day. Can you please? Okay. All right. So let's see. So welcome. We are at the top of week 7, right? So we're going to be wrapping up chapter 1 today with section 1.6, composite functions and combining functions and composite functions. But what that means is that we can anticipate exam 2 to become available this upcoming Sunday. Now, right now, I'm under the impression that this upcoming Monday is fall break. So, I mean, I have to check and confirm the dates, but I think we're going to have this upcoming Monday and Tuesday off, so we won't be meeting live on Monday, and we'll just meet Wednesday of next week. So we'll probably just take that day to kind of, I'll probably just, treat it like an exam day. But I just have to confirm the dates, and I'll probably send an announcement or something of that nature. So you can anticipate exam 2 to become available this upcoming Sunday at 11:11 a.m. and it'll be due the following Sunday at 11:59 p.m. Same deal. So let me check Zoom again so I can try to get more of you guys for the announcements. So if you're just joining us, we were kind of making our way through the announcements. We're at the top of week 7, which means that we can anticipate exam 2 to become available next week, right? I think I scheduled it for this upcoming Sunday at 11:11 a.m. and it'll be due the following Sunday at 11:59 p.m. And so that brings us to like the midterm, right? So there's not a midterm exam, it's just exam 2, right? And so the way I think for you all that I calculate the midterm, if you kind of ignore the lab component, like without the lab, then basically 80% of your grade comes from the exams, 10% is homework, 10% are the quizzes. But then I'm going to take whatever that score is and I'm going to scale it to 90% of your overall grade. And then the other 10%, whatever Dr. Lamar, sends me as far as your records, I'm going to take that and I'm going to scale the grade that you get from her to 10% of your grade. The lab is 10% of your overall grade. So hopefully you've not only been making your way through Pearson and getting those things submitted, but you've been collaborating with Dr. Lamar for the lab component. I can't think of anything else. So yeah, today we would like to go ahead. I'm gonna check one more time. We're usually missing like one student. I'm gonna see if okay. So I had to try to track down these guys. Okay. So we're going to be wrapping up chapter 1, and exam 2, you can anticipate it to cover basically the second half of chapter 1, but by default, mathematics is typically cumulative, right? We can't talk about stuff at the end of chapter without using things from the beginning of the chapter. No, stop. No, I know, lay down. No, get down. Come here, lay down. Thank you. She loves to bark at any noise that she hears. Okay. So yeah, we'll be working on section 1.6, combining functions and composite functions. And a few objectives here, we like to define the basic operations on functions. We like to form composite functions, find the domain of a composite function, decompose a function, and apply composition to practical problems. Okay. So, today, like none of the classes, none of the sections have made it past objective 3. It was just the way this section is set up. Now, if you want to see a presentation for parts, objectives 4 and 5, that should be available in my pre-recorded lecture that's on my YouTube. All the stuff that I'm doing is already available. I just do it just to be filling this area. I mean, we could just meet and I sit in silence, you know, and then just until you guys ask questions. But this is just the way I prefer to do it, you know. I'm just doing it just because. So here we have, let's go like this, Sum, difference, product, and quotient of functions. So let f and g be two functions, then the sum f plus g, the difference f minus g, the product f times g, and the quotient f divided by g are functions whose domain consists of those values of x that are common to the domains of f and g, except where for f divided by g, where all values of x that make the denominator 0 must be excluded. These functions are defined as follows. So this is read f plus g of x is basically the function f plus the function g. F minus g of x is the function f minus the function g. F times g of x is f times g. F divided by g of x is f divided by g, where g is not equal to 0. So a common error that students do, so this is function notation, right? This is not multiplication. A common error is that students try to multiply by x. That's not what's happening here, right? I saw where students would distribute an x and then it would throw everything off from that point. Again, what this is function notation. So this means f of x plus g of x. This means f of x minus g of x, so on and so on, right? So it's not multiplication, it's function notation. Okay. All right. So this has kind of been crashing on me all day. Didn't work that time. Yeah. Okay, I'll be right back because I have to reboot this. Let me see, we left off here. I think I need like 3 pages. 1, 2, 3. Okay. Let's review. Seamless. Okay. So given this f of x and this g of x, find the following functions. Okay. So let's take some notes. So we're given that f of x is x squared minus 6x plus 8, and g of x is x minus 2. So then for part A, we're asked to find f minus g of 4. Part B, f divided by g of 3. C, and then f plus g of x. I think I got the rest of here. D, f minus g of x. E, f times g of x. And f divided by g of x. Okay, so let's take this part by part. So for part A, it looks like we're evaluating f minus g of 4. Okay, again, we're not distributing a 4. What this means f of 4 minus g of 4. Okay. So let's evaluate f of 4 on its own. F of 4 going to be x squared minus 6x plus 8. Notice I replace each x with a blank parenthesis. Then I'm going to plug in my 4. Okay. 16 minus 24 plus 8 ends up being 0. And then let's go ahead and find g of 4. It's x minus 2. So then that one's going to be 2. So then this ends up being 0 minus 2. And the final result is negative 2. Okay. And then, so for part B, they asked us to find f divided by g of 3. Okay, this means f of 3 divided by g of 3. Okay. F of 3 off to the side is going to be x squared minus 6x plus 8. Our x in this case is 3. This ends up being 9 minus 18 plus 8. It's negative 1. Okay. And then let's go ahead and find g of 3 on its own. It's going to be x minus 2. We get 1. So then this f of 3, we said that f of 3 was negative 1. G of 3 we said was 1. So then the final result is negative 1. Okay, as usual, if anything isn't clear, you have to feel free to unmute yourself to get my attention and we can talk about it. Okay. So then part C asks us to do f plus g of x. Again, this means f of x plus g of x. So then that's going to give us x squared. Here, let's be consistent. That's going to give us x squared minus 6x plus 8. We're going to say plus x minus 2. If we combine like terms, x squared stands alone. We got a negative 6x plus x gives us negative 5x. Okay. And then 8 minus 2 is 6. Okay. So then the next part asks us to do f minus g of x. That's going to be x squared minus 6x plus 8. But this time we're going to put in the parentheses and we're going to say minus x minus 2, right? Again, the previous example, we didn't need the parentheses because we weren't doing any distributing, but because of that minus, we need to distribute the minus. So, you know, the parentheses help us to be like, okay, oh, we need to distribute the negative. So then if we do that, we get x squared minus 6x plus 8 minus x plus 2. Combine like terms, x squared minus 7x plus 10. Okay. Okay, so then the next one, f times g of x. Again, what this means is f of x times, let's be consistent. This means f of x times g of x. Okay. So then this is going to be x squared minus 6x plus 8 times x minus 2. Okay. So we need to FOIL, right? Or distribute. Every term for f needs to be multiplied by each term for g. Okay. So if we distribute properly, we'll get x cubed minus 2x squared, and then minus 6x squared plus 12x, and then plus 8x minus 16. So then we get x cubed. Combining like terms, we got an x squared here. That's going to be what? Negative 8x. That gives us 20x. And then minus 16. Then f divided by g of x. This means f of x. I need some more space for this one. F of x divided by g of x. So our f of x we got x squared minus 6x plus 8. We want to say that divided by x minus 2. Okay. So looking at the top, it looks like we might be able to factor it into a form like this. We're looking for two numbers that multiply to give us 8 and add to give us negative 6. So then what? Negative 4 and negative 2? Negative 4 times negative 2 is positive 8. Negative 4 plus negative 2 is negative 6. So then here, we should have, before we got to this stage, it's a good idea to identify that, hey, notice that x cannot be 2 because that makes a 0 in the denominator. Okay, so now this binomial is canceled by this one, and we're left with x minus 4. Again, we still need to acknowledge that x cannot be 2 because that makes 0 in the denominator of the original function. Even though the denominator is gone, because it makes 0 in the original, we need to throw that x value out. 20 minutes, right? I've been talking since 9 o'clock. Like I'm always struggling. Like by the time I get to you guys, like by 3 o'clock and you guys, I just feel like I'm dead. Like I just want to like sleep. And so it's like I try to end just a little bit early so I can like squeeze in like a quick power nap for you guys, but it's tough. But anyway, let's keep going. Okay. I think we're good here. So let's go single page, right? So here's all our work with our results, right? We got -2, -1, these guys and this, and then here's the type version of what we just experienced. Okay. I think these are all okay. Okay. So we've talked about combining functions, right? Where there's all that is basically adding, subtracting, multiplying, and dividing functions. So now we have this other concept that's called composition of functions. Let's take a look at it. If f and g are two functions, the composition of function f with function g is written as f composed g and is defined by the equation f composed g of x is f of g of x, right? Where the domain of f composed g consists of those values of x in the domain of g, for which g of x is in the domain of f. Okay. So what this symbol is saying, what this means is f composed g of x, this just means the second function inside the first function, right? A common error that students make with this symbol, they think it's multiplication and they multiply. If you multiply f times g, you're going to be led astray. This symbol just means the second function inside the first function. So it's a function of a function within a function. Okay. And let's see it in action. And then for the domain of a composite function, there's a 3-step procedure that we do. We'll take a look at it. And this slide just kind of like is like a pictorial representation of where the domain of the composite function comes from. The domain of the composite comes from the domain of the inside function, where the inside function is also in the domain of f, right? So don't worry too much about this. Again, when you see it in action like once or twice, then I think it'll sink in a lot better than that one. Okay, I need like 1 page. Yeah, I just don't know why it's been crashing when I do this. All right. I got to reboot it again. Okay, I think that's where we left off. This one. I think I only need 1 page. Okay. So given that f is this and g is this, we're asked to find the following. Okay, so let's take some notes. We have that f of x equals x cubed, g of x equals x plus 1. Okay. Thank you. So then for part A, we're asked to find f composed g of 1. For part B, we're asked to find g composed f of 1. And I'm running out of space here. Let me give myself some space. Okay, so then for part C, we're asked to find f of -1. Okay. So then for part A, f of g of 1. This means, again, the second function inside the first function. So it's going to be f of g of 1. Okay. Let's do g of 1 off to the side on its own. That's going to be x plus 1 ends up being 2. So then now that means we're going to find f of 2. Okay. So if we do f of 2 off to the side on its own, that's going to be what? 2 cubed, which is 8. So then the final result is 8. Okay. So then for part B, we're asked to find g of f of 1. Okay. This means g of the second function inside the first function. So that's going to be, now we have f of 1 is on the inside. So let's do f of 1 off to the side on its own. F is x cubed. So there's going to be x cubed as 1. So then this is going to be g of 1. G of 1, let me see, g is x plus 1. Okay, so I think we had 2 from earlier. So g of 1 is 2. And then part C asks us to evaluate f of negative 1. Again, this means the second function inside the first, so this means f of negative 1. Oh. Oof. Okay, so let's do f of 1, f of negative 1 on its own. It's going to be x cubed. So I think that result ends up being negative 1. And we're doing f of negative 1. And it's going to be a repeat, basically. This one ends up being negative 1. Okay. So we got 8, 2, and negative 1. Okay. You see the 8. You see the 2 and the negative 1. Okay. Let me see. What's the time? Okay. So I'm going to kind of, did I do this one? Okay, I'm going to kind of match, just for the sake of time. I want to get through the next one. So I'm going to leave this one that was going to be in the recording, like in my pre-recorded lecture. Let's do part B on this one. And this will be it for the day. This is what I had to do with everybody else. I'm just kind of matching, you know. I think with each of these sessions in the description, I put links to the full recording. So where we only made it through a little bit past halfway, about half of the section. The remaining half is in my pre-recorded lecture, right? Okay. So let me add a page. Do I need a page here? Yeah. Cool, it didn't crash this time. Okay, let's start here. So given that this is our f and our g, we're just going to do part A. We're asked to find f composed g of x, and its domain. Okay. So then our f of x is x plus 1. Our g of x is 1 by x. And then we're just going to do part A because we're almost out of time. We have f compose g of x and its domain. Okay. So if we're doing f compose g of x, this means the second function inside the first function. So this means f of g of x, okay? So this is going to be f of 1 by x. So what we're doing, we're basically rewriting x like f of x like normal, but we're replacing each x with the green thing. Ouch. I don't know. I'm just getting weird pains in my body out of nowhere. Oh, okay, let's keep going. It's just distracting, if anything. It's just distracting and annoying, but it's fine. Okay, f of x, right? So our f of x is x plus 1, but again, we're replacing the x with the green thing, and I think that's our simplified form. Okay. So then to find the domain of this composite, there's a 3-step procedure that I do for that, right? Okay. So for the domain of composite. Okay. First we want to find the domain of the inside function. Secondly, we want to find the domain of the simplified function. Okay. And then third, we want to take their intersection. Okay. So in our example, if we want to find the domain of f compose g, first, we need to find the domain of the inside function. Okay. And that's going to, in this case, that's going to be the domain of g. Okay. So g of x is 1 over x. So that domain is going to be all reals. Okay. So with g, the domain there is going to be all reals except any x that makes the denominator 0. So we got to throw out x equals 0. Right? So then the domain of g is going to be everything except 0. Okay. So then secondly, we want to find the domain of the simplified function. Okay. So that's going to be here. The only restriction here is that we cannot divide by 0. So it just turns out that that one happens to be the same thing. X not equal to 0. Okay. And then the third step is to take their intersection. Okay. So if the first set is everything except 0, and the second set is everything except 0, intersection is what do these two sets have in common? A set intersect itself is itself, right? So x not equal to 0, intersection x not equal to 0 is the same, is itself, right? And then in a graphical representation, let me clean it up a little bit. In a graphical representation, say here's 0, we want to capture everything except 0, right? So that means we want all the numbers to the left of 0, we want all the numbers to the right of 0, and because we don't want the 0, that means we're going to capture with a parentheses like this. So then to go from this graph to set notation, the far left on this graph is going to be what? Negative infinity. And then we want all the numbers from negative infinity all the way up to 0. And we want all the numbers from 0 to infinity. Infinity always gets a parentheses. Because we don't want 0, we're going to group 0 with the parentheses, and we combine this with union, right? And so then this is the domain. And so that, that's not trivial. It's not obvious. I think I ended with M6. Ow. Okay, let me see. It's like I don't know what that is. It's just distracting. So let's go single page. Right, so you see the domain, the simplified function at the top with the corresponding domain, everything except 0. And then we did part A, right? So 1 over x plus 1 and everything except 0. Okay, I think that's enough. Are there any questions? Did you all have any questions for me? Okay, because that's pretty much the same stuff we did with everybody earlier. Let me go ahead and make a copy of this PDF available. So I'll send it to Box. And basically when this bar finishes loading, you'll get a PDF copy of everything you saw me writing. You can use it for your reference. So on Wednesday, what we'll do, we will go through as many homework questions corresponding to this section as we can. If there aren't any burning questions, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day, guys. Okay, take care. Peace.